और भाई क्या हाल है? Let's move to this question. The question is put in a hard category, but I'll say it's easy. It's just that the implementation of this question is a bit tricky, but it's easy. Like if you have watched earlier videos of mine, I have made you guys do kind of like 90% kind of same question. So yeah, let's see this question. In this, it said that we have been given strings s and t, and now we are allowed to remove any number of characters from string t. So we can remove the characters from string t. Okay. The score is of the string is 0 if no characters are removed from the string t. Let left be the minimum index among the removed characters. Let right be the maximum index of the removed characters. Okay, the score is right minus left. So it's just that from T I have to remove some characters. Let's say from leftmost place I removed a character, it's left. Rightmost place I removed a character, it's right. In middle also I can remove something, but in total, like from the removable area I have removed, let's say it is the string T, I removed here, here, and here, and here, let's say. So I'll just see the left, which is leftmost removal. I see the right, which is the rightmost removal, and I'll just do a right minus left plus 1 to get the score of this removal. Now I need to return the minimum possible score to make T a subsequence of S. If you don't know a subsequence, it is just that the elements needs to be in the order, which is like if the elements of T, which means the characters of T, it needs to be in the order in S. That's it. It's just that it needs to be in order. It can be like this: A, B, C, D, E, F. So it can be like A is here, let's say in S, A is here, B is here, and some characters are here, C is here, and then some here, and D here, and then like this. Okay, now you guys know what the question is. Let's quickly run through the example. Although the example is not that much helpful, but yeah, let's quickly see. So if the string S for me here is this A, B, A, C, A, and it is my T, and now I need to make my T a subsequence of S. So B, Z, A, A, B, okay, Z, I cannot find Z. So I need to remove something in here. Let's say I remove Z, so I get a BAA. BAA. Good. After removal of Z, which is the one character, I got my BAA, which is actually a subsequence of S, as I showed you, BAA. Now let's move on to the next example. Although the example is not very helpful, we will make our own example to get through it. With this X, Y, and Z, okay, X I cannot find, Y cannot find, Z cannot find. I have to remove all of them, which means all of them being removed. Now it is an empty string. Empty string is a subsequence of every, it's a subsequence, it's everything of every string. So S is, now the T is a subsequence of S. How many characters I removed? I removed 3 characters. Answer is 3. Here I removed 1 character. Answer is 1. Okay, now you guys know. Now let's see some better examples to get. So like basically I have, like I just made this video earlier also, in that I explained, but now I thought that I should be ready with the proper, like legit proper examples. So yeah, let's see. So here, as you can see, let's say my S is this, which I define here as A, K, B, C, L, G, H, M, D, E, N, F, O, P, and my T is A, B, C, I, G, J, H, K, D, E, F. Now, as you can easily see that my I, J, and K, it's not at all in the S string, so I need to remove them. I remove this I remove this J, I remove this K. Now, as you can see, now the remaining string is A, B, C, G, H, D, E, F. A, B, C, G, H, D, E, F. Now my T is a subsequence of my string S. You will agree on that part. But if you will look at this, so the score, here it is low, here it is high, right? So the score of this removal will be high minus low plus 1, right? Now you will say, Aryan, the score of this removal was high minus low plus 1. So why do I care? Even if I remove this G or H also. Even if I remove this G or H, still my A, B, C, D, E, F. A, B, C, D, E, F. It's still a subsequence of S, right? So why I should care for the elements which are in middle? So I can easily say that now I need to remove a substring from this T. I removed a substring from this T such that some elements remain in the starting, some elements will remain in the end, and from that I can easily make a subsequence of S. Agree on that part? Okay. Now, which means that now I need to make a T such that I'll just see the prefix of T and I'll just see the suffix of T, right? Now we both know that we just need to remove the middle part and I just need to consider end part and the start part, which means that the end needs to be the subsequence of S, which means F, this string from end, this string from end, which is the string T from end, it needs to be a subsequence of string S, which means I go here, F I found, okay, then I move to E, okay, E I found, I move to D, D I found, okay. Now I need to go from the starting in the prefix of T, so A I found, good, B I found, good, C I found, good. Now I can easily say that A, B, C, D, E, F, which is the prefix plus suffix, it is the subsequence of my string S. Now, yeah, from this example, we got to know that, okay, if we just remove this substring part, which means we just have the prefix part and the suffix part, and see if that suffix and prefix, it can make a subsequence in S, we are good to go. We don't have to look for every element inside the T. We can just go from end and from start. Now to do this, as we can easily see that the time complexity, the constraint of this question is that the length of S and T, it can both be 1e5, which means that I have to pre-compute something. It is not that for every prefix I can move to every suffix. It can't be like this, which means that for every I, let's say I'm moving I from starting and let's say J from ending. So at every prefix, if I'm moving like this and like looking in the S string, I cannot look for the same prefix also simultaneously, because I just need to do this proper thing in artmax O of n or artmax of O of n log n. That's it. So I need to pre-compute something if I want to do it in O of n or O of n log n. Okay, good. Now let's see how we will do. As I said that what we need to do. As I said that for the suffix part of my T, I need to figure out, okay, is there a subsequence in S? If there is or not, right? So I'll do the same thing. What I will do is that I'll move, I have this example, S is A, B, A, B, A, and I made this example specifically so that it's easy to understand every concept required in this problem, because the examples given are not that great. So the T is A, B, B. So as you can see, the length of this T is 6 and the length of here it is 7. My S is 7. Now I made an array called DP, called prefix common, sorry, suffix common, anything. I'll call it as DP because it's kind of you are storing storing in the memory about existing thing, which means that you're pre-computing something. So yeah, I named it DP. Now what I do is I have my I pointer. I have my I pointer at the back of my string S and the J pointer at the back of my string T. Now I just move my I and J. If I find the element, let's say if I look A, B, no, it's not same. I move my I. B, B, oh, it's same, which means that nice, my B, B, it can come. Okay, so to store that, okay, which location of I can find my latest B. Understand? Which location of I from the back I can find my latest for this particular B. It is this 5. So I stored it inside here. For this index, which means 0, 1, 2, 3, 4, 5, which means the index of T. This index of T, it stores the latest index which I can find from back of S. Good, pretty good. Now my I is here and J is here. Now as it is matching, okay, no worries. I just move my J here and also my I here. Oh, is A matching? Voila. Which means that it is my latest J from the end it is my latest I from the end for the string S, which is matching with the J of string T. Okay, now I will just put it inside my array that, okay, the location for it is the, see, the indexing is for string T and this value is for string string S, the index I. Now, as my elements were equal, I just move my J here and my I here. But as you can see that my A and B, it doesn't match, right? So I just need to move my I. You are sure, right? Why I'm not moving my J? I'm moving my I because I need to make J, which means the string T, as a subsequence of string A, which means the string A can have, like, it can be like this: A, B, C. It can have gaps, but the string T, all the elements needs to be subsequence of this S. So I just move, okay, it's not same. I have to move my I. I moved my I. Oh, it's still not same. I have to move my I again. B and B, it's same. Nice. So for index 3, which means that for my T at index 3, I can find in my S at index I at index 1, I can find my same element, exactly same element which I want. Very nice. I put a 1 here and I just move my I and J again. It is my J, it is my I, A and A. It matched. I'll just put it as a 0 and then I moved my J, I moved my I. Oh, I string is finished. Now I can't just do. So I just can by default put the values of the remaining as -1, -1. But I'm just concerned about these values. Now you can easily understand what these values represent. It represents that, it can easily represent that at index, at let's say at this index, if I just go above, so I can easily find that my BAB, it can form a subsequence in my string S, and from where? Starting with the index 1. Starting with the index 1, as you can see, 1, which is this, A, which is this, and B, which is this. From here to here, I can easily form a subsequence in S for every index, any index I want. Let's say if I want this one, so I can just say that, okay, it is the subsequence. Let's say if I am standing at index 2, which means the T suffix is this whole part. So I can easily say that starting from index 0, I can easily find a subsequence in my string S, which means that starting with this index 0, 0 here, 1 here, 4 here, and 5 here. So it just represents that, okay, how long can I have my subsequence in S for any element in T, right? And -1 represent that, okay, it's not possible to have that suffix as a subsequence in S. Now, good, we have got the suffix part. Now let's compute. As I said that for every prefix we need to find every suffix. So nice. Now, as we have found out that, okay, what would be the suffix part, now let's move on to the prefix part, which means that for my substring, which means for my prefix of T, I will find, okay, is there any subsequence in string S by which I can see, okay, my prefix of T and my subsequence of string S, and then with the help of the array, which is array of DP, which we made earlier, with this help we can find that, okay, what would be the length of my L and R, which means that I will have the prefix of this much amount, suffix of this much amount, which means that I have to remove the mid whole of this amount elements. So I will just minimize this removal of mid elements, which means that I will just minimize the removal of this subarray by maximizing this prefix and suffix sum. Now let's see how we will do. Same as earlier, I will just have an I for my string S, my J for my string T, and let's say to iterate on this array of DP, which is storing my maximum for that particular suffix, how at what index I am being starting, like what is the maximum index I am at to get that suffix from that string S. Good. We'll just move on to this K, which means that I am at this I am at this J. So at what K I should be, which means that my K will initially be here. Okay. But we should always remember that my K should always be pointing to a value which is actually more than I, because I can't, let's say if it would have been a 0, let's say if it would have been a 0, I can't be standing here, because if it says that I am having a prefix from here and my TP spoke about that I will have a suffix up till that, so if it overlaps then it's of no sense. So I am just saying that okay, my I is here, earlier it was 1, which means that I can have up till this suffix, I can have a subsequence of suffix in my string S, which is this, and this, right? So it just says okay, I can have this as a subsequence in my string S. So what I will do is, for this I, as it is same, my I and J was same, I just say that okay, for this K, I'll do how many elements needs to be removed? Logical sense, if my prefix is here, my suffix is ready, I need to remove the elements 2 here, which is these two, right? So what I will do is, I'll do a K is pointing here, J is pointing here. So I'll do a K minus J plus 1 to grab the number of elements in between K and J. It will give me number of elements between K and J, and K represents number of elements with which we can make a suffix subsequence, and J represents number of elements with which I can make a prefix subsequence in string S. Okay, good. Now as my J was same, I just moved my I forward. Now my I is here and it is gone. My J is here. It is not same. Okay, I need to move my I because I need to make a subsequence of T, right? So as I see, A and A are same. Okay, nice and good. But my I is 2, which means that I need to grab an index of array DP which is more than 2. So I can't be standing here. My K needs to go far, which means my K will now land to this, where the value is 4, which is actually more than 2. So I am good to take it, which means nice, which means that I'll grab this prefix, I'll grab this suffix, which means this and this element, right? I guess you guys got it. So with this, I can see that okay, for my this K, which is at 4, I grabbed these elements and these elements. How many elements are in between? 2, right? Because my J was pointing here. So I just have this J, which is index 1. So 4 minus 2, which is 2. It represents these 2 elements. Nice and good. Now I moved my I forward. Okay, and my J also forward. Now my J is B. You get the sense, right? This element is B. Now it is not equal to A. Okay, move my I. Still it is A, not equal to B. Move my I. Now my I is this, my J is this, both are equal. Nice and fine. But in my array of DP, I need to have an index in a value which is more than 5. So I will just go more than 5, but 5 was last. Okay, go beyond it. I just went beyond it, which means my K is 6 now, kind of. So my K is 6. So it just says that, okay, if I go now A, B, this means this, and this. I can't have anything in suffix now, right? So how many elements I need to remove? Which is K minus J plus 1. K is pointing here, which means it is pointing here. I grab all these elements. So the elements remaining are all these, right? So I need to remove these three elements with this, as you can see. K minus the 6. Now K is 6 minus 3, which is 3. Now you guys got to know, right? We firstly find the suffix and pre-computed that, okay, what all subsequence which we can make via this. After that, we found, if you guys can see, yeah, this is. After that, we found for the prefix, and simultaneously we keep on. And after that, it's just the minimum of this. So like we can have this minimum simultaneously, right? It is option 1, option 2, option 3, which means that for every I am going and J I am going, so every K I am seeing, so every step I'll compute it. Now let's quickly see the code. So it's just that the implementation part was a bit tricky, that how we implement it, because right, you have to monitor K, J, I, all three variables. So firstly, my S size is SS, my T size is TS, my K, as I said, in every step my K points to DP, my I points to my string S, my J points to my string K, my string T. Now my J points to my string T, my K is for my DP array, and it is like this. Now what we do is we made a DP array, well and fine, of the size of T. Now we iterated on my array int, but it is for the suffix part, right? It is for the suffix part, as we said that we need to pre-compute something. So we will just move on, we will just start from the ends I and J. I points to end of my string S, J points to my end of string T, and K is at the end of my string DP, vector DP. Now I see, okay, if it is same, then just place my I at my DP of K and just reduce J and K, or we can easily do by only K itself. It's also still fine. And after that, when it is done, which means my suffix is pre-computed, I'll just go to my answer, because as I said, my answer will be pointing to a K, because as my K is reducing. So in my last step, if my K was pointing here, so it will point here where it was star I showed, right? Now let's say it is value 0, 1, 4, 5, so it will point here. So ultimately I need to increase my K, right? Because it was pointing here because of this step, -1. So my answer would be this K plus 1, which represents that it is index 0, 1, 2. It represents that I need to remove these two elements. Answer represent I need to remove these two elements, as in the indexing is 0, so you understand why I did a K plus 1. Now, well and good. If my answer is 0, I'll just return a 0. I don't need to remove anything, right? Now I just do a prefix computation and simultaneously doing a minimum answer, as I showed why I did this, K minus J plus 1. Understand? Which I showed in the code also, in the explanation also. And here it is that if my simple condition that it should not go beyond the bounds of my length, and if it is equal, then I just increase my K, and I just keep on increasing my K. And if it is equal, then I just did minimum of my value, because both elements are equal, right? So I can see, okay, my prefix goes good, my suffix I need to find, okay, I have stored in my array DP, let's see what's the minimum combined, what I can get. And then I increased my J, because I'm moving my IE forward, J forward, and here I'm moving my K forward. Here I'm moving K forward. I hope that you guys got the intuition, and I hope that you guys liked it. If not, then you can just let me know in the comments below, and see you guys next video. Until then, bye bye, take care.